Hello. I'm going to show you a nice little problem that includes some basic concepts in density and geometry and properties of matter. What you're looking at here is a thin piece of palladium. Palladium is a very malleable metal and can be hammered into very thin sheets. And as you can see as I talk, it kind of flutters. Well, I have a full sheet here. Whoops. And I'm going to try and determine the thickness of this sheet. And the way I'm going to do this, we could pose it as a problem to students, is to measure the length and width of the square. And we know the length times the width times the thickness would be the volume of the palladium. And if we combine that with the density of palladium, treating the thickness as an unknown, we can calculate the thickness. So it's a nice little problem, and it brings in some chemistry, properties of elements. Palladium, like gold, is a very thin metal. Now, you don't have access to palladium. You could use aluminum foil as an example. It's a nice little problem, and I hope you enjoy it. So in the next part of the video, we'll see the results of weighing it and calculating the thickness of the palladium. So thank you for your attention for this part, and we'll see you in the second part. So the problem we have is to find the thickness of a piece of palladium foil. And I would suggest just posing this as a problem. Don't give them any information other than how would you experimentally determine the thickness of the palladium foil. After seeing how thin it is, there's no easy direct way to measure it. What would be a way of doing it? With simple materials that you have around your house or a lab. And of course the solution is to, well, first of all, measure the length and the width, and I have the experimental values there, 8.7 centimeters, 8.7 centimeters. The thickness is unknown. That's what we're looking for. What is the thickness of the foil? Well, we could also measure the mass. That's pretty straightforward, and that's 0.0130 grams. Okay, so that's the mass. And now, how will we measure the thickness? Well, the key, of course, is to use density. So let's determine the mass. Let's determine the volume. The volume is length times width times thickness. The volume is 8.7 centimeters times 8.7 centimeters times T. So the total volume is unknown. We just have T as the unknown part. The density is 12.02 grams per cubic centimeter. That we looked up. It's a fairly dense solid. The formula for density is mass divided by volume. So we substitute in mass 0.0130 grams times divided by the volume, 8.7 times 8.7 times T. And that's equal to the density. And we solve for T and get 1.4 times 10 to the minus 5 centimeters. Very, very thin. You can carry this further and kind of do another problem. Is how many atoms thick is this palladium foil? And we might tackle that in a future YouTube video. So nice simple problem to determine the density, to determine the thickness of a piece of palladium. As I said, you can use aluminum foil if you don't have palladium. I inherited this piece of palladium, but you might be able to get it, or gold foil, if you look on the internet. I haven't done that, but I'm sure that can be done. So thank you for your attention, and I hope this is useful, and I'll see you next time.